Right. So transpose of matrix can be calculated mathematically in this order. Yes or no? Okay. So rows of first column becomes columns of a transposed matrix. Okay. So this you have to do in the program. Okay. So first matrix you take as A, and first matrix you take as A, and second matrix you take as a B, which is nothing but transposed matrix of A. Okay. So the trans B, if you print, it should be the transpose matrix of B. B184. Clear? Okay. So this program now will write here. Okay. So quickly, already you know how to uh, read elements into the matrix. Okay. So program find transpose of a matrix. Okay. Clear? So quickly I copy this from this, so that only one matrix we required. Okay. So this is the code for reading elements into the matrix. Okay. So we required only two matrices here. Third matrix we don't require here. Then what we do is, here we take a m by n matrix. Okay. So m comma n, this time we call the rows and columns of m and n, and we required a two for loops. Okay. So two loop control variables we take here. Enough. Okay. So enter rows and columns of the matrix, you say. Okay. So it is now you read into m comma n. M by n matrix we have. Then transpose matrix should be of n by m size. Okay. So enter percentage d elements of the matrix, you say. Okay. So here percentage d should be m multiplied by n. Okay. So m by n elements. Now you have a matrix with you. Now you need to find its transpose. Store the transposed matrix in a B. Okay. Right. So how to write code for that? That means for each row you store in column format. Okay. That means this 0 0 should be stored in a 0 0. Just see here how it can be generated here. First matrix and second matrix. Okay. So that means A of 0 0 element should be stored in a B of 0 0 position. Okay. Similarly, A of 0 1, this element, the second element, should be stored in a B of 1 0 position, like this. Okay. So if you understand this, how it can be written, then you can write a loop here. Then using that loop, you can generate the code here. Okay. So matrix transpose I am trying to find here. Okay. So here I am calculating transpose. This is the code for generating the transpose. Okay. So what you can do is, you repeat the first matrix for its rows and columns. For I is equal to 0, then I less than m, number of rows of first matrix, then say I plus plus. Okay. Similarly, repeat another loop for number of columns of a first matrix. For j is equal to 0, then j less than a number of columns n and j plus plus. Okay. But only thing is, here you have to store in this form. Okay. So for b of ji, Okay, now we'll see here B of ij, m by n matrix, no, here. Okay, so yeah, B of ji you have to say here, B of ji should be equal to A of ij, A of ij. Now this is the code for this. Now we will see whether it generates the transposal matrix or not. If you execute this loop, whether it generates correctly or not, quickly we'll see these two for loops. Okay, now see here, assume that our matrix A is 1 2 3 4 5 6. Matrix A is 1 2 3 4 5 6. Okay, this is our A matrix. Okay, 1 2 3 4 5 6. Okay, now B you have to generate, B matrix you have to generate here. Okay, so a 2 by 3 matrix you have to generate. Now first I value is 0. Now I am executing these two for loops. Just here, I value is 0. 0 less than, what is the order of this matrix? This is 2 by 3 by 2 matrix. Okay, so 0 less than 3, yes, then enters this loop. J is equal to 0. Okay, so what is J value here? J is equal to 0 here. 0 less than 2, yes. Then B of ij, B of 0 0, this element. Okay, so this element I am calculating here is A of ij, A of 0 0. Okay, so 1 will be stored here. A of 0 0 is 1, 1 will be stored here. Okay, so then it goes to J plus plus, inner loop executes first. J plus plus, J value becomes a 1 now. Okay, so J value becomes 1. 1 less than 2, yes. 1 less than 2, yes. Now see here, B of J I. B of J means J is 1 and J I is 0. B of 1 0. Okay, row 1 and column 0. This element I am calculating here is equal to A of ij, A of 0 1. A of 0 1 is what? 2. Okay, so then 2 I am storing here. 2 I am storing here. Okay, so then J plus plus, J value becomes a 2 here. 2 less than 2, false. 2 less than 2, what is n value? N value is 2 here. 2 less than 2, false. Okay, so immediately it goes to I plus plus. So I value becomes 1 now. I value becomes 1 now. Okay, now see here, first row we stored as a first column in a transposed matrix. Okay, so I value becomes 1. 1 less than 3, yes. So again enters the inner loop freshly. Okay, so again J value becomes starts from 0 onwards. J is equal to 0. 0 less than 2, yes. Now see here, B of J I, what is J value? 0 and I value is 1. B of 0 1, 0th row, first column. Okay, so this element I am going to store. Okay, so B of 0 1 is equal to A of ij, what is I value? 1 0. Okay, row 1 and column 0, that means 3 will be stored here. 3 will be stored here, that means second row I am storing as second column. Okay, just see here, so then J plus plus, J value becomes a 1 here. Okay, 1 less than 2, yes. B of 1 1 is equal to A of 1 1. Now see, A of 1 1 is 4, that will be stored in a B of 1 1 in this position. Okay, so similarly 5 6 will be stored, again I plus plus, I value becomes 2, 2 less than 3, again this inner loop repeats and it copies this third row as a third column here, 5 6. Like this the transpose matrix will be calculated here. But when you print the transposed matrix, okay, so you should remember the order there. You should remember the order carefully. Okay, so now if I print the transposed matrix, what is the code for printing this? Yeah, this is the code for printing resultant matrix, no? So I just copy this, then say return 0. Here I copy the code here. Okay, so the transposed matrix, you can say here the transpose of the matrix is. Okay, so here you should remember it should be m by n. Okay, so m by n will become n by m, so that's why you should, columns will become now rows, rows will become now columns. Okay, so you should write here I should be less than n and j should be less than m. Okay, so here the second matrix is B of ij If you print, then it will be printed in the form of a matrix transpose. Okay, so return 0, then say close the main function. That's it. Then you will get this one. Okay, so execution part, if you want, quickly I'll show the execution of this. Then say new file will open. I copy this here. Okay, then for printing the transpose matrix, just I copy this here. Okay, so then return 0, close. Okay, so I'm saving the program. Okay, so here transpose, I say transpose.c. Okay, so I'm building the program. Just see here, 0 errors. There are no errors in the program. So now run the code. Now enter rows and columns of a first matrix. So what order we stored? 3 by 2 matrix, no? Okay, so 3 by 2. Enter 6 elements. Okay, so 1, 2. Okay, so then 3, 4, then 5, 6. Now see, the transpose of the matrix is 1, 3, 5, 2, 4, 6. Okay, so even you can enter a 4 by 2 matrix or 4 by 3 matrix, you enter, then you will get a 3 by 4 matrix. Just see here. For example, enter rows and columns. Okay, so 4 by 3, I say 4 rows and 3 columns, 12 elements. Okay, so 3 elements, say 1, 2, 3. Okay, then 4, 5, 6. Okay, so then 7, 8, 9. Okay, so then 10, 11, 12. Okay, now you can see I'll get a 3 by 4 matrix. 1, 4, 7, 10 printed as a row, and 2, 5, 8, 11 printed as a row here. Okay, so each column converted into row in the second matrix. Clear? Okay, so this way you should develop the logic. If you by heart the programs, you never get. You need to develop the logic. Okay, so logic, how a logic can be implemented in the program, this you should understand. Then you can write any kind of program, even 100 200 lines of code you can write on your own. Clear? Okay, so we'll stop here.